Right, good afternoon again, everybody. As you can see, our next speaker is Arthur Clune, who's Head of Systems at York University. And Arthur's team is responsible for running the storage, the virtualization, Linux, Unix, that sort of thing, all the databases and systems and services. So he's going to talk to us about DevOps, and if that means nothing to you, then maybe you're at the wrong presentation. It's very interesting to me. Edinburgh University is something we're very much focused on, so I'm very much looking forward to hearing Arthur's talk. And also hearing about the changing characteristics of provisioning infrastructure and what that really means for our traditional ways of making things happen. So I'm looking forward to hearing all about this. So I'd like you to welcome Arthur to the stage. Thank you very much.
Right, thank you very much. Yeah, DevOps. So we've had a lot of sort of very high level, very strategic type talks. This one will go down a little bit more into the weeds and then pull back out again at the end. So we've got a mixture of the technical and the non-technical. Okay, so this is basically the theme of the talk, that it's not the 90s, but a lot of what we're doing is the 90s. We haven't really advanced. And the difference between best and worst is getting bigger and bigger and bigger and bigger. And so what I want to try and convince you of is that if you're not doing this stuff, you should be doing this stuff. And that the gains from doing it are really very significant indeed. Before I do that, I'm going to wander off at a slight tangent. So this is a graph from a guy called Simon Wharton, who does a talk called Situation Normal, Everything Has Changed. It's on YouTube. I highly recommend you watch it. On this graph plot, on the bottom, it's got certainty. So over here we have something that's very well planned. Over there we have something that's unknown. So you've got this research project on the left, delivering water out of your tap on the right. Really well planned engineering problem. Not necessarily easy, but understood. And then going up the axis, we've got ubiquity from rare to ubiquitous. So adoption speed is and what he said is that you start off here, so this is a research project, then it becomes custom built, then it becomes productized, and then as you go further up, somewhere up here you end up with utility. So you can think of this as being your Lions, Teams, vertical piece just after the Second World War. Up here we've got AWS, Azure. And as you move from one stage to the other, what you get is a conflict. You get a move. So he talks about war and peace, and war and peace are commercial terms. So if we think back to sort of the mid-90s to about the mid-2000s, that would be, in this sense, a period of peace. Company A competes really hard with Company B. And Company A builds great desktop boxes about that big by that big, and they run some version of Windows. And Company B builds boxes by that big, running some version of Windows. So there's competition between firms, but the paradigm within which they are competing is the same. What's different now is that we're at one of these inflection points. So in the same way that your DCs were wiped out by Microsoft and the transition to the microcomputer era, we're having a similar one now, where we're moving from desktop PCs and laptops, which are basically the same thing in a different form factor, to mobile devices and to cloud at the two extremes. And so everything has to change. This is the final slide assignment that I'm going to use. I don't know if you can read Enterprise IT Adoption Cycle. How many of you are in this phase over here, which says, oh, deep? So what I want to convince us all is that we need to be up here. We need to be moving a bit faster. There's quite a lot of people who have talked about that. This is some ideas about how you move faster in the enterprise space. Okay, so I said infrastructure practices haven't changed, but you work in infrastructure, you're doing these things all the time. All the networking guys have to learn all about wireless, wire propagation through Windows, and why it doesn't work to just stick an access point in a doesn't go through your nice new buildings, walls, and all this sort of stuff. The systems guys perhaps learn new operating systems every couple of years, new storage platforms, new everything. So it's all changing all the time. Except that actually, there really isn't changing that much all the time. How we work, not maybe what we're doing, but how we work hasn't changed. A couple of nice, somewhat blurry pictures of some Microsoft MMC AD plugins there. How fast can you click? And how repeatable can you click? If you're setting up 7 Hyper-V servers or 7 VMware boxes, how are you going to get them the same? Because they won't be. If you're doing it like this, they will not be the same. No matter how much of a checklist you follow, they will be different. It also strictly limits productivity because at the bottom end, it's quite easy to have a sysadmin or a developer with really quite high negative productivity. We try and get rid of that. But it also really limits the top end because how fast can you click? So let's look at a different sphere within IT. So this is the commonly cited figure for how productive developers are. 10 to 1 ratio good to worse. Again, we'll exclude the guys that have negative productivity. They're there, but we try and get rid of them. Now, there's a lot of debate over this exact figure. Is it 10 to 1? Is it 100? Whatever. Yeah. It's commonly regarded, and I think our experience will back it up, the gap between the best and the worst software developers is enormous. Okay? Now, how do we translate that? How do we take advantage of this figure in the infrastructure world? And I've been mocking GUI slightly, so all the Unix guys and Linux guys at this point will go, wait, great, we've got CLIs, we can just run SSH over everything. That doesn't work either. Greg Farrow's a networking architect, networking consultant, great Twitter feed, it's quite amusing and a good blog. This sort of stuff, show IP, EIGRP topology when your network routers. Fine when you've got 10. Doesn't work when you've got hundreds. Certainly doesn't work as you get into thousands of servers. How many servers have you got? How many VMs have you got? How much can you scale? Okay, let's look at another. So step away from what we're doing and let's look at what the hyperscale guys are doing. James Hamilton is a cloud architect for Amazon AWS. Again, another great blog if you're interested in data centers and hyperscale design. This is their server to sysadmin ratio in AWS. Now, this is what he admitted to a couple of years ago. I would imagine it's actually better than that. And when I quote that number of people that are working in sort of traditional IT, they will say, well, that's really unfair. Why are you telling me this? Their system's not like ours. They've got all this lovely green fill. We've got all this legacy cruft. Oh, yeah, we've got lots of legacy cruft. And it is unfair. It's completely unfair. But it's a very relevant comparison. And it's relevant because they're how many times more productive than we are. I did the numbers for us. We're at a couple of sort of 200 to 1 is our ratio here. And that's pretty good. In some of the sort of academic departments, we're at 2 to 1. For central IT, we're quite happy with that. Now, how do you get up to that sort of number? This is one answer. So this is what Netflix do. A guy called Adrian Proctor used to be CTO or similar at Netflix, and now Battery Ventures, which are a venture capital firm. And he coined this thing NoOps. So Netflix doesn't have operations staff. It's not strictly true. They have a very small number of operations staff that run their HR system and their payroll. But it's tiny. Everything else lives in Amazon. Only in Amazon, a very big Amazon user. Developers write code, developers run tests, developers push straight to production. Go straight line. How do you know it's going to work? Well, you've got this guy here who's a chaos monkey. And they now have a whole simian army, they call them, of these things. So how do you know your system is resilient? Well, you pick a server and you shoot it in the head. The guns. And you don't power it down, or they do this during the working day randomly on live servers. They just power them off hard. 30 goods on Amazon. They take them down. And everything should work. And they have a chaos gorilla now that takes down an entire Amazon, all their servers within an Amazon AWS availability patch. So, yeah, we're all infrastructure, let's all go home. Okay, we'll just let the developers do their stuff. Now, I want to stay employed, so I'm obviously going to say that's not the case. But I think it is. It's not just because we've got lots of legacy as well. I mean, we're all going to be kept employed just to run with the legacy for the next 20 years. But I'd like to think we can do better than that we can add to that. So let's start at the bottom. Your network is always going to be needed. There's no point having cloud services if you haven't got a network. Your databases, your systems, they'll move from on-prem to cloud. And if you go back to that Wardley chart of utility versus ubiquity, I don't see private cloud as being a sensible point on that graph. You go all the way to public cloud. You might transition through something on the way, but I think that's not going to end up. But how do you manage it when you got it all in the public cloud? Well, actually, it's not that dissimilar to how you manage it if you're running on-premises. You still need the same skills. You just don't have to go and worry about the disk space. So you lose a relatively small amount of the task and you keep quite a lot of the rest. So, if we're going to do it, how do we do it better? How do we get more productivity? Well, we're going to code it. That's it. Hashing for code. A lot of this stuff happens on Twitter. What these ideas came about on Twitter. That's quite a good hashtag to follow on Twitter. Infrastructure as code. What does it mean to talk about infrastructure as code? Because infrastructure is not code. Infrastructure is key. But before we can really make sense of what it means to say infrastructure as code, we need to know how coding works and what does modern software development practice look like. Because back in the day, let's say you were writing a website, well, you'd tap it away into Notepad, you'd FTP it onto the web server and you'd call it a day. And again, we've still got people that are doing that. And when you wanted to change it, you'd move it to a directory called .old, put the new one in, and then you'd forget about the .old, and then someone would hash you through the .old, and it all goes a bit wrong. So, software development has improved. This is your classic waterfall diagram. Okay, we start at the top, we go out, we talk to users, we get their requirements, we design our system, we implement our system. At this point, the requirements have changed, so our system is actually out of date anyway, but hey, we've got to keep going, we're going to push on. Okay, so we've implemented it, so we're going to push it into production. And then it will... You've got this divide between dev and ops. And if you don't close that gap, you try and push this stuff into production, and OS versions don't match, your library versions don't match, you've got DLL hell, your developer's got some random cron job running on their desktop that they forgot that's crucial for the system but isn't documented anywhere. There's so many ways this thing can go wrong. We've heard a lot about bimodal IT, and one of the problems I have with bimodal IT is how do you close this gap? If you're saying, over here is legacy IT, and over here is new shiny, what does fit in the middle? How are we going to talk to each other? It's not that the ideas are wrong. There are differences between legacy and new, but I think there's more points of similarity than that binary distinction shows, really. Okay, so just while we're talking about some DLL and things like Docker, one of the reasons that Docker becomes so popular is that actually it solves this particular problem really nicely. And it's taken up in scientific software because scientists write software. They're not software developers. It's not portable. It only runs on their desktop. And it's usually a complete pain to install. But their colleagues want to use it. So now they can try and produce a Docker image and do something and just deliver that and say, I've installed it for you. Here it is. Now, a slight diversion, really. So let's go back to what a modern software development process looks like. So rather than doing the waterfall process or any variants of, we have the whole Agile methodology: code, build, test, release, deploy, operate, monitor, and keep going back around. We do that in nice tight iterations so that we get some requirements and we implement them, but they're a small set of requirements so that we can implement them before they're changed. And we deliver the minimum viable business value that we can. And we deliver it quickly, and then you iterate and you do it again. The other important things here: monitoring, testing. really key to how modern software development works. You can push frequently, you can do lots of changes. People like Netflix are changing their production system 100 times a day. And they can do that because they've got tests, so that they know they've made a change and they've got some certainty they haven't broken anything. Facebook was down yesterday apparently, so this doesn't always work, but for the volume of changes they're making, the amount of downtime they have is really very impressive. So this is the theory, and as the old saying goes, in theory, theory and practice are the same, but in practice they're not. So to do this in infrastructure is hard, and I don't think anybody is actually doing the whole thing. But what we can think about is, how do we take bits of this? How do we step towards it? How do we improve what we're doing? Okay, so if we're going to pick out some key features of modern software that we want to take and we will apply to infrastructure, what do we think? Okay, so agile projects we've talked about. Revision control. Even on the developer side, I don't know how many of you are in development, but how many of your institutions actually have all of their custom code in source control? I can see some shaking heads. We've had quite a lot of work to get most of it in, and we've still got bits and pieces that either aren't or they're embedded in business systems from which it's really hard to extract them. That's really quite hard. Tests, again, continuous integration. So continuous integration is where a developer makes a change, they commit it to source control. The tests that are associated with that package or program or whatever it is are automatically run on commit. And you have something called user Jenkins that will run those changes and give you a nice green flashing light. And if it passes the test, then you push it to production. And that's an automatic pipeline. Check, if it passes the test, it goes live. And finally, A/B testing is more of a web thing where you'll test two versions. So rather than having this shocking pink on the left, I might do 50% of these folks with a nice blue colour. I'll do some feedback and say, do more people like the pink or the blue? If you'll say you like the nice shocking pink, then I'll stick with that. So the movement that takes these ideas is DevOps. That's basically where it comes from. One of the interesting things about DevOps is that DevOps is actually a European movement. We're used to thinking of a lot of the innovation in the IT space as coming typically stateside. This was started in 2007 in Belgium by a Belgian IT contractor called Patrick Dubois, who was interested in working not just across infrastructure but also across development, and saw these differences in approach. Saw developers using source control tests, and saw the infrastructure guys just typing into terminals. So this was 2007, which is relatively recent, obviously. However, some of the ideas behind this are actually relatively old. So back in the early 90s, around about 93, the School of Computing in Edinburgh University had something called LCFG, which is a configuration engine. CF Engine was written by a guy called Mark Durgis, who was then at the University of Uppsala in Sweden, a similar sort of time frame. And there's also infrastructure.org, which is where some people wrote up what they did to the deploy desktops and servers for a trading system for a bank in a similar time frame. But what was different then was that those were very isolated. They didn't really take off as a movement. This took off on Twitter, so I've written it as a hashtag. And that's, again, another good hashtag to follow. The other thing about this is that all of these tools really came from the Unix side of the house. They were not in networking, they were not on the Windows side. Networking engineers are inherently conservative. And they're inherently conservative for a very good reason. And the network breaks, everything else breaks, and then they get the blame. So networking guys are not keen on new ideas. Windows didn't pick this up because automating Windows is actually pretty hard. You're useful for a Unix box with the ability to take a text file, dump it on some servers, and maybe restart a service. We'll come on to what Microsoft's doing in this space in a bit, but really it's sufficiently hard that only Microsoft can make that work. Okay, so we take that list of requirements and then we translate them into infrastructure. We get something that looks like this. I want it to be declarative. So I want to say, install a web server. I don't want to say, apt-get install Apache Steve. I want it to be completely repeatable. I want two web servers. I want them the same. It should be testable. It's going to have to be code or textually based so that I can diff it, I can source control it. And possibly more debatable, but personally I like my systems open. So I'd like an open source product so that I can actually see what's going on, I can debug it, and I've got some sort of exit strategy for it. And even more crucially, certainly for York, is something that doesn't charge per box, so that gets really expensive. Right, a small digression. There's a shark at the top and a dolphin at the bottom. And this is an example of parallel evolution, convergent evolution. So both of these animals want to move really fast through a dense viscous liquid. They want to go fast through water. And they want to be agile and they want to turn fast. So what do we get? We have a dorsal fin, we have some steering fins, and we have something that wags at the back to make you go. And really the main difference is that in mammals it goes up and down, in fish it goes side to side. They're solving the same problem, they end up in basically the same state. Okay? So just keep that in mind. Because when we start to look at what a software management system for infrastructure might look at, there's only so many ways of doing it. And at the biggest, highest level, they all look like this. We have some sort of master that contains our config, with a load of clients that either push or pull, but in some way get their config. So that's the classic 10,000 foot view. I don't know how readable that is. But this is an example of actual code. So this installs a directory, copies all the files in the directory. File, etc., SSH, ensure it's present, ensure it's a directory. Recurse means copy all the files underneath it from the source. Source tells you where to get it. And then we've got a notify service, SSHD, so if anything in that directory changes, tell SSHD, restart it, make it completely fine. And here, very similar example. File my example, ensure it's present, type directory, recurse is true, source file, select start file, destination path is a bit of a giveaway, c:/inet pub www.read. So this is Windows. This is PowerShell DSC, that one's public. Now, I confess I've picked examples that deliberately look very similar, but you get the point. So, one of the things about this is, on the Windows side, is that this is really very, very cutting edge. PowerShell, DSC, or design of state configuration is, well, we're looking at it, but I wouldn't want to run it in real production just yet. But it's advancing very, very, very fast. Microsoft are putting a lot of effort into this, so they've gone from big fat clients where you have the GUI and everything on your server, to Windows Server Core, we don't have the GUI, and now you've got Windows Server Nano, which is even smaller still and can really strip down to just the minimum components. And you can see that what's driving this is that they have to operate Azure. And the only way to operate Azure is this sort of stuff, because it doesn't scale to do it any other way. We've been playing with this, we've looked at deploying SQL Server on Windows Server Nano using PowerShell. It's moderately painful at the moment, but it's not going to be very long until that works. Okay, so we're done. We'll just call it a day. We've all agreed we're just going to code everything. We'll all go home and we'll all live happy ever after. And unfortunately, it's not quite that simple, because life never is. So, let's just talk about what it's actually like in production. So the big thing is, infrastructure is hard. Designing a network is hard. Running an AD that doesn't crash is quite hard. Running 400 Linux boxes is hard. Writing code is hard. Developing reliable code is hard. And now we're going to try and do both of them at the same time. On the surface of it, it might not seem like much of an improvement. software engineering is a discipline, and it's a discipline for a reason, which is that it's hard. So, are we all going to do UML diagrams all day? Probably not. So this is what we've done in York. So I said DevOps started in 2007. We started playing with Puppet in early 2008, and our first commit to our production Puppet repository, which we're still using today, was in late 2008. So that was our first production system that was deployed via Puppet. We deploy 6 via Puppet fully. We can also deliver a 6 application server and have it spun up. So we had a case recently where we really need some more application servers because we had some of it load, spun up some more servers. It took about half an hour. University of Oxford have done this as well for the same product. We're running VMware NSX. All the build scripts for that are now all in PowerShell. So when we want to stand up an NSX server, we run it in PowerShell. As I've said, we're investigating PowerShell DLC and we're playing with that and SQL Server. That is definitely not quite ready for production, but it's certainly something to learn. And we actually have some tests on some of our infrastructure. There are lots of sums in that sentence because we could be an awful lot better here. But when you're looking at these things, something like the example we had earlier where it was just copy a file, you don't really need to test that because either it works or it doesn't. It's copied the file or it hasn't. But when you start coming to do more complex things and you want to write a recipe that says give me a web server, but you want to parameterize all of that, and you want to allow for different configs, different vhosts, different names, then that's code. There's if statements in it, there's parameters to it, and those are things you can test. And how do we test it? Well, exactly the same way. We bump it into Jenkins. So some actual figures from York's production environment. Lines of code. Lines of code is not the greatest metric in the world, but orders of magnitude of lines of code is actually a really good metric. 100-line script is easy, 1,000-line script is a bit more complex. 100 million lines of code in your BMW or your Volkswagen lets you hide your emissions problems. So we have got 75,023 lines of Puppet, and that is not the configuration files that are deployed by Puppet, that is actual Puppet code. Now in itself, that's actually a fair-sized system. In our systems repository where we have sort of the scripts that copy data around, that are quoted on our filers, all that sort of stuff, we've got nearly 250,000 lines of code. I was quite surprised actually at that one. The network config of all our switches is in source control. That's 560,000 lines of code. It's not code, 560,000 lines of code. And just to put it in context, our dev team has roughly 5 million lines of code in their repository. But you know, we're heading towards the same order of magnitude there. Sort of about 750,000 lines of code. And we haven't done lots of the infrastructure. So basically this is where you end up. That we get all the ops problems we've always had, plus all the development problems developers have always had. We have Puppet libraries that we're quite afraid to touch because they're base libraries that everything else includes, and you have the opportunity to wipe out every one of our servers in one go. We have problems when we had Puppet 2, Puppet 3, which changed the language in some fairly minor ways. But when you've got that much code, actually porting from Puppet 2 to Puppet 3 was a fairly major project. So, okay. The thing is, these are basically good problems to have. They are signs of progress because they're better than the alternatives. I have a mortgage on my house. Now that is a bit problematic because I have to pay it every month. But you know, it's still a good thing overall. And the thing is, these are basically, if not solved problems, then problems from which a large body of art exists in the developer world and in the CS world. A bunch of buzzwords just to think about here. Some of these are ops terms, some of these are developer terms. Microservices, so compartmentalization. Don't write your systems so that they all suck everything together. Reduce your base to the minimum. Similarly, two-pizza is the idea that if you're writing a service, this is an Amazon term, you should be able to code review and tests, fairly obvious things to have. Anti-fragility is a movement and an interesting thing to go and look up and do some reading around. And anti-fragility says that rather than trying to control change, reduce change, and push it through cancels, understand how systems work and that systems fail, that bits of systems fail. Make your system resilient to failure. And in some places you can do that. Okay, if you've got an edge router that fails, and the people that are connected to that are not going to be getting any network connection until you go and replace it. But, if you're running up some web services, if you make it easy to spin up the boxes, then you can load balance. And let's make it easy to configure the load balance. The other things that come along are things like immutable infrastructures. So Puppet and PowerShell VSC are about we stand up a box, we change its configuration, and the tool makes sure that the configuration running on the box matches what we've got. And then we change our source and we change it again. Immutable architectures are something that comes out of the web scale world. Again, Netflix pioneered this. You stand up a box, you never ever change it. If you want to change it, you spin up another one, you change your load balances point over here, and you destroy that one. If you want to roll back, you change your load balances to roll back. The other things, obviously, things like Docker. Docker is a relatively low-level format, so Docker is a way of running many things on one machine and within one kernel. But above that is where all the innovation is happening. So Docker, the company, has effectively made Docker the Docker product an open standard. But that's just one VM, essentially. How do you orchestrate lots of these things? So what people like Google do is they're not deploying machines, they're deploying code. Google has a product called Google Borg. Apache Mesos is the open source version of that. And I highly recommend reading the research paper that Google released about Google Borg. And what Google Borg does is it lets developers deploy, and they don't care where it runs. The system will put it on a machine that matches. So you say how much RAM you want. You say what guarantee of latency you want from your disk. And it sorts it all out. And that's clearly where development and infrastructure are going. How we get from there to here, I'm not entirely sure. But that's the direction. And then at the far end, you've even got things like unikernels. So a unikernel is you compile your entire application into the kernel and remove everything else. Mirage OS is a good thing to look at. They've got a demo of a web server where it actually effectively boots the VM for every page load. Because it's so fast to boot, it's so small, click on a link to a new VM to serve it for you. And what that gives you is really good security management tools. And it's an interesting option to use it. So there's a lot of reading around that I'll highly recommend. Okay, so that's the end of the technical bit. Last couple of minutes, I'm going to talk about this. There's a tension, or at least a perceived tension, between infrastructure and DevOps. Between wanting to push 100 changes a day and wanting to have a weekly CAB meeting with a pre-search. How do you square that circle, and what do you do? So you change your culture. That's what you do. If you remember nothing else about this talk, this is the most important slide in this talk. DevOps is not technology, DevOps is not product, DevOps is culture. It's your teams talking to each other. Okay? DevOps is not a job title. If you're employing DevOps engineers, you're probably doing it wrong. Okay? DevOps is cultural change. It's about breaking down those silos. And we go back to that bimodal IT piece. Again, that's where I see those problems coming in. Are you really just going to do this sort of agile, fun things over here and carry on doing it over here, just like you've always done for the last 20 years? Well, you should. I need a bit in the middle. So, there's a famous William Gibson quote that says, "The future is already here. It's just not a hidden industry." This is really where we're at. The gap, as I said before, between the best and the worst in IT is now huge, and it is getting bigger. We need to do our bit to close that gap. And the final thing, maybe to go back to the cultural piece, all of this stuff, all of the DevOps movement comes from practitioners. did not come from the vendors, it did not come from management. Free your teams. Have good staff, let them do things. Listen to what they say, encourage them. And if you do it right, you should be able to do more changes with less downtime, less disruption, and faster service delivery, which is what we all want. Just to give an example, speaking to a friend at another university, they have a PCI network, as we do. So they want to monitor all the changes on their PCI network. So they type changes into their switch, they take a copy of that config and they put it into SharePoint. This is doing it wrong. Okay? That code should go in the version control system, which generates your diff, which emails you the diff. So you can see automatically what's been changed. And that is not hard to do. If you're a Cisco shop, there's a product called Rancid, or open source. Otherwise, 100, 150 lines of code to write something that will monitor a directory, drop a config in, make it source control generate with it. So how do you reconcile the ITIL world and the DevOps world? Yes. You have tests. Consider what a standard change should look like. Do you define a standard change by impact, or do you define it by danger? And if it's by risk, by danger, then tests will help. And maybe that moves something that wouldn't be a standard change to a standard change. And then you can start churning the changes, because velocity matters. I'm going to leave you, basically, with one question and two demos very shortly. This is a question that somebody posed, and it's really quite a profound question. We version code. We have release 1.0, and then we have a bunch of patch releases. What version is your infrastructure? We cannot answer this question today. This big number down at the bottom here, that is the SHA-1 of the Git head of our Pocket repository. So that is the version of a fairly small part of our infrastructure. Things like software-defined networking. We bought VMware NSX can help with this by pushing some of that configuration of not just VMs, but VLANs, firewall policies, port groups, everything else into software, and then you version it. So that's where we're going next. That's what we want to do to try and close this gap. And let's just see. So I'm afraid this is a relatively low-res screen, so this is quite difficult to see. This is something that somebody in our development group wrote. So this looks live at the code that's on our web server, written in Cold View. And total applications 91. There's a blank bit here, and I think it says 100 over there. This says still using VSG globals.cfm, so basically this was something we didn't want to be doing. And just putting this on a dashboard and making it visible, 100%. It's driven change, makes things visible. Similarly, what percentage of our applications are web deployed? 47%. It's going up, and it's going up quite nicely. And the other thing I wanted to just show you before we finish. This is our new monitoring page. So each of these blocks, so this is eVision, the website, Pure for our research system, password management wiki. These are true end-to-end tests of the entire system, from the web applications all the way down to the database and back. And this is now public on the university website. And if you click through some of these things, the ISA services tweets over there, click through these and you'll get taken to something that will tell you a little bit about what it is. This sort of thing is not easy to do. This is 6 months' work for one person full time. But once you've got it, it just enables so much other things, because we've got an awful pile of monitoring infrastructure now that we can do lots of stuff with. We can alert on trends. We can alert on threshold numbers. Is it up? Is it down? Let's go back. So, we've got about 5 minutes for questions. less of a leap for the Unix guys because they've always done a little bit of coding. For all of the numbers in total are big in this, generally each individual bit you write is relatively small. You're writing scripting size pieces. It is a big leap for the Windows guys. For the Windows team to learn PowerShell, for some of them that's too much. But if you're a Windows sysadmin and you can't code PowerShell, you will not be employed in 5 years' time. That's where we're going. That's where the industry is heading, and you have to keep up. No, because we've been doing it for quite a while now, and we didn't have any metrics before. So. Yeah. So I think it comes back to what we started with earlier. This is driven by the practitioners, and this was not a management initiative at all. I started with a colleague writing those first public contents back in 2008 when I was in the sysadmin type role, security role, and it's grown from there. And it spreads because people see the benefits over time. So once they see, we've had an incident, our SIP system's overloaded, we need to bring up another application system. Boom, look, we've got another one. That's a really good selling point. And IT people, it's interesting stuff. If you want to learn this stuff, it's a good skill to have. Your old skills are still valuable. You can learn new skills. People like learning new stuff.
I guess one of the final things that I thought was quite important was that with one of the problems that I observe is that you mentioned 2 types of developer. In fact, I think it's not just the sole kind of domain of developers. You see a whole characteristic, a spectrum of productivity through different types of people working in organisations. That's true of every organisation. However, what I tend to find is that people who are particularly effective, maybe in terms of overcoming change or doing new things, tend to become less effective when they're asked to do repetitive tasks over time. And I suspect that that might be something that DevOps and that movement DevOps tends to overcome. It keeps things fresh, it keeps people moving on. I mean, how do you feel about that?
I couldn't agree more. It removes the repetition, and that helps. But again, if we go back to the skill level, this sort of thing will show up the differences between the best and the worst. You have to deal with it. But there's more good people than you think, maybe. I see.
Hi. I think this has been a really good talk. Thank you very much. There's sort of chunks of it that I know we've been doing, so I'm really interested on your sort of 10 to 1 observation. I think in terms of the repetitive tasks, I've noticed amongst the sysadmins we've had in our department, there are some that when faced with repetitive tasks will take the time to automate that as far as they can and to adopt these principles. But there are others who will just keep on doing those repetitive tasks. I think that's maybe a sort of a binary difference in a way rather than a sort of scale of 1 to 10. I think that's questions. I think my final comment would be that PowerShell is a shame.
Questions at all, or is that? Okay, well, thank you very much, and thanks again to Arthur. So a round of applause, I think, is absolutely